Hello everyone, this side Priya Bhatia, and in this particular video I'm super excited to tell you that I'm launching a new separate playlist for the machine learning as requested by a lot many students. I hope that after listening this thing you are also super excited. Now what we will cover up in this video is I'll try to give you a gist of machine learning, what is that all about and what we're going to cover up in the upcoming modules. The major prerequisite to understand this complete playlist is that you should have a clear-cut idea behind Python programming language, the very first thing, which I'm expecting from everyone to know already. You should have a good understanding of the concepts of stats, which I already have been covered up in my separate playlist for stats for data science. You should have a good knowledge about linear algebra, eigenvalues, eigenvectors, those concepts which we already, understood in our, I would say, lower classes of 11th, 12th, or in our bachelor's as well. In discrete mathematics per se, if I'll specifically talk about. Whenever need will come, I'll also explain the things, but not in very much depth because I'm pre-assuming that you already know all these stuffs. So let's get started with the very first topic, which is what is machine learning, why and how it is, okay? So as you can see on my screen, unleashing the power of machine learning, what, why and how. This is what we're going to cover up in this particular session. So let's get started. We'll start with the introduction of machine learning. After that, we will talk about how many different types of machine learning techniques that we have, what are the applications of this particular domain, challenges that we usually face, what is the future, and finally we will end up this session with the conclusion part. I hope you all are excited with me. So let's get started with the introduction part. Now, what is machine learning? I hope that you already have heard of the terms like machine learning, AI, deep learning. If I'll ask from you, what is the difference between these three terms specifically which I am saying, AI, ML and DL? Whenever I am saying AI, it's a complete, I would say, superset or a bigger circle, which basically is a complete system which imitates the human behavior. Okay. When I am talking about machine learning, what it is simply a subset of that AI, where we usually pass a historical data. On the basis of that, we usually want the prediction from the model that we are training. So basically, in machine learning, what we are going to do is we want our model to learn from the data that is being driven by human behavior only. For example, I'll just give you one simple example. For example, I just want to predict the house pricing. You definitely have seen or go through a lot many data set with respect to the pricing of the house, right? So what usually happens is we usually tend to, I would say, send so many amount of data set that we have with respect to the locality, with respect to the number of bathrooms that house is locating, with respect to the number of bedrooms, with respect to the locality, with respect to the balcony. And on the basis of that, these are the something which I am calling as a features. And on the basis of that, the pricing will be decided. Now, on the basis of these records which I am fetching up and passing on to my model, I can predict that, okay, what should be the price of this particular house which I am talking about, right? So this is what we call as a machine learning domain. And when I'm talking about deep learning, it is further a subset of a machine learning. So basically, if you will observe, there are three key terms that we have. One is something which we are talking as an AI. I'm saying it's a bigger circle where a complete end-to-end system we will be able to see. Inside that, we can see that there is something that we have is, I would say, ML, machine learning, where we are passing the data set, historical data. And what we want is, without being explicitly programmed by any programmer, we want the output predictions. And then inside that, we will be having something called as DL, deep learning, which basically imitates our human brain, right? Here comes the concept of neural network that we're going to see in the future sessions. Now, in today's session, our focus is on this domain, which we are talking about as machine learning. Okay. Now, how many different types of this machine learning that we have. One is something that we will be talking as supervised machine learning. And as the name suggests, supervised machine learning meaning that here whatever data you will pass. So as I told you, in machine learning, we are passing something called as historical data that we trained our model on. So here we are passing something that we called as historical data. Now, depending upon what type of data that you are passing, there are different unique types or categories of machine learning techniques that we have. So when I'm saying supervised machine learning, what I really want to say here is that there is a supervision which is going to happen. How? Here you will be having something called as labeled data. Labeled data. What does that mean? The simple meaning is that what usually happen is, for example, here you are trying to do any classification task. Classification task meaning that maybe you really want to pass the features of cat and dog, and you want your system, your machine to predict, your model to predict that whether this belongs to a cat or a dog. So when I'm saying cat or dog, this is kind of a classification task. You are trying to classify between two classes, cat versus dog, depending upon the features that you are passing to the model. Now, when you are passing the records, suppose you are passing how many number of records? Maybe 1000 number of records. In 1000 number of records, you are passing a target value. And this target column indicates either the category as cat or the category as dog. So when you are passing these records with their target value or with their labels that okay, this particular record number 1 belongs to cat or record number 50 belongs to dog. So there is a class which you are passing side by side, right? And this may be represented by 0 and this may be represented by 1. So in that particular scenario, this is something that we called as a supervised machine learning task. Or, so in supervised machine learning task, you will try to solve two problems majorly. One which I have talked about is classification task. Another problem which you can solve is the regression task in supervised machine learning technique. In regression task, what will happen is, here you don't have the as such classes that I am talking about, but here you are trying to predict some continuous number. You are trying to predict some continuous value or a number. What does that mean? For example, just now I gave you the example, right? House price prediction. House price prediction. So here what will happen is, let me open it again. Oops. So this will be lost, but it's okay. I hope you will be able to get an idea what I was saying. So we will be talking about a supervised part. And in supervised, I was talking about a regression scenario. So when I'm saying regression, so in regression, I was giving the example of a house price prediction. So whenever I'm talking about house price prediction, you will observe that here in house price prediction scenario, we are trying to predict a continuous number. How? You will be having some decimal number. Maybe house belongs to 2 crore. So your target value is something which is having some number 1.78 crore or 7 crore and so on. So what I am saying here is, here also target value is given to you, because whenever I am talking about supervised machine learning technique, that is for sure that label is given to you, target is given to you. But depending upon what kind of problem you are trying to solve, your target value will change. Either you will solve a classification kind of a problem in supervised task, or you are solving a regression problem. When I am saying classification, there will be a classes, maybe 2, 3, 4. For example, just few seconds back, I gave you the example of cat versus dog. In regression task, you will be able to predict a continuous number. For example, I gave you the example of a house price prediction. So that is the type number 1, which I have talked about, supervised machine learning. In type number 2, the second important technique that we have in machine learning, which is called as unsupervised machine learning technique. In unsupervised, what usually happens is, as the name suggests, there will be no supervision. Means whatever data you will pass, that historical data, with respect to that particular data, there is no as such labeled data will be there. There is no labeling or a target column will be there. Just like that we are seeing on the above part, where I have talked about that in supervised you will be having a target column. What I am saying is, in unsupervised there is no as such target column will be there. So in that particular scenario, what will happen is, you will be, your model, your system will try to find out the patterns. When I'm saying patterns, similar sort of patterns. For example, if I will give you one simple example of this, is customer segmentation. For example, I want to segment customers. I want to make clusters of the customers. For example, there are few customers who is having a category spending high quality. They spend maybe per month, their expenditure of their spending rate is too high. Then I create one another cluster which belongs to a similar group of people who is having a spending quality of moderate rate. And then maybe the third cluster will be there, which is having a group of people which is having a very low spending rate. So what we've done here is, we have created three segments of customers. Customer A, B, C. A quality belongs to a group of people. So here basically you are doing a grouping of the people which belongs to similar category, which belongs to similar distribution, by looking into the nature, I would say. So here basically our model will try to find the patterns, and on the basis of the patterns it will try to do the segmentation, or this is what we called as clustering. This is what we called as clustering. That is grouping of similar kind of data. Grouping of similar kind of data. And this is something that we called as, I would say, unsupervised machine learning technique. The important thing is that here we don't have any labeled or the target column, just like we have in supervised, right? Now, apart from this, there is third important type that we have. The first one we have understood supervised, second one we have understood unsupervised. Third one is something which we have is reinforcement learning. Reinforcement learning. So whenever we are talking about reinforcement learning, here there is some sort of action to be taken, and on the basis of that action, there will be either some reward or penalty will be there. So on the basis of environment, our model try to learn. Okay, so it will take some action. On the basis of action, either some reward will be given or a penalty will be there. Now, whatever be the self-driving cars that you are seeing today, or there will be a boom after some point of time of self-driving cars as well. So in that particular case, this reinforcement learning is there. So in this way, there are three important categories of something that we are starting today, machine learning. One is something that we have understood as supervised. Another one is something that we have understood as unsupervised. And the third one that we have understood as reinforcement with their applications, right? So in supervised, we have seen that it will be basically helpful to solve two problems or two tasks, I would say. One is the classification task that we have learned, and another one is something that we have is the regression task, right? And I have given the example of both of them. I hope this part is also pretty much clear to everyone. Now, again going back to the presentation, so we have seen what is machine learning. It's a subset of AI that involves the use of algorithm. Statistical models will be there. That's why I told you it's a prerequisite to learn the stats first, to enable the computer systems to learn from the data without being explicitly programmed. Now, let's move ahead. Types we have understood, it will be supervised, where training is done on labeled data, useful in classification and regression tasks. I already have explained what is these tasks. After that, we have seen unsupervised, where the training will be done on unlabeled data. I have already been talked about that. Clustering, anomaly detection, it's useful. I have already talked about that. Reinforcement, where there is an agent which will do the action, which will try to maximize a reward. Useful in self-driving cars. Moving ahead, now what are the applications of this machine learning? Why we are studying this? Why it is required? Is there any usage in future scope as well or not? So the very interesting application of this machine learning domain is in healthcare. I remember when I was doing my master's, my thesis project was completely on healthcare domain. And I was amazed at how basically this domain can be helpful with respect to the healthcare domain as well. For example, if we want to diagnose any disease, whether a patient is cancerous or not, whether a patient is having a COVID or not, whether a patient is having infectious lung or not, all these things can be done nowadays with the help of this machine learning tools, right? Apart from this, if we want to see the drug discovery, we want to get a recommendation of a personalized treatment, all these things now you can see are there, right? Even I'm not talking about tier 3 cities. I'm not sure that whether these things will be applicable or not in the hospitals or not. But in tier 1, I'm 100% sure that these tools are nowadays working on, right? And there is lot more to do in this particular domain. There's a lot more research is going on. There is lot more building and development part is going on, specifically in healthcare domain. Second thing, in finance, again, machine learning plays a very important role. If suppose someone wants to check that whether this person is fraud or not. So in case of a fraud detection, this particular tool is important. Credit risk assessment in banks, it will be really helpful. Similarly, in marketing, to analyze the customer behavior, again, this machine learning plays a very important role. So you can see, right, starting from healthcare to marketing, everywhere nowadays, machine learning is something which is quite helpful, quite important. And that's the solo reason that why, data science domain is quite booming and everyone nowadays is talking about data science, right? Now, in this particular case, we will talk about further what are the challenges of machine learning. Now, okay, we have talked about that a lot, but is there any challenges whenever we are creating some model, whenever we are dealing with some kind of a data? What are the challenges that we have in machine learning? The very first challenge is high quality data, right? See, I told you in machine learning, we are training a model by passing the data set. And the more quality of data you will pass to the model, it will be able to generate the better results. But now the challenge is, do we have that high quality data? No, we don't have. We used to spend a lot more time in doing one step called EDA, exploratory data analysis. Few days back only, I have uploaded one video regarding EDA, right? So the very first thing is high quality data which is not available, and where development team, researcher team spends a lot of time so that they will be able to get a high quality data, because data plays a very important role. If data is not clean, if data is not of high quality, we will not able to get a better results. Second biggest challenge is interpretability, where again the work is going on. See, if suppose in healthcare domain, your model is saying that a person is cancerous, or it's saying the person is not cancerous, why? Can that model explain the reason behind that? It might be the case that the logic or the reason that model is understanding why the data that we are passing might be wrong. So we have to see the explainability of that particular result as well, where again much work is going on. And the third important thing is the privacy concerns and the biases. See, we don't want our model to lose the privacy of someone's other person, or we don't want our model to be biased towards one of the result and it will forget about the other classes that we have. So we have to take care about the privacy concerns and the biases as well. So basically, these three are the major challenges that usually we find whenever we are solving any problem with respect to machine learning: high quality data, interpretability, and the privacy concern and the biases. Now, moving ahead, many people usually ask, is there a future of machine learning? Definitely yes, a big yes. Why? Because the solo reason is nowadays we can see that as the time went by, data is increasing a lot, right? Whether we are talking about social media techniques, or whether we will be talking about education part, whether we will be talking about finance part, whether we will be talking about healthcare part, in every domain you will observe data keep on increasing, and it will increase. And that's why the development of deep learning came after machine learning, because deep learning involves neural network which basically have a power to detect the complex relationships in a data also, which machine learning don't able to do that. So we will talk about deep learning in a separate video, but yes, there is a bright future whenever we are talking about machine learning, or specifically we are talking about AI or data science domain, right? So in conclusion, what we can say is machine learning is a powerful technology and it has a potential to derive innovation and transform the industries. By enabling the computers to learn from data, machine learning helps organizations make better decisions, improves the efficiency, creates the new opportunities. But by saying that, we have seen today that it comes with challenges itself that we already have been talked about. So in a nutshell, what we have learned in today's video, we have talked about what is machine learning. We have talked about how many different types of machine learning that we have. We have talked about what are the challenges that we have, what are the opportunities that we have. We have seen that is there a future in upcoming years with respect to this particular domain, and ultimately we have talked about the final conclusion that okay, this is what we have, that's fine, but there are still a lot more to do, there are still a lot more to learn, and I'll talk about that in future, that after some point of time you will observe that when data becomes too huge, even machine learning models that we have will get failed, or they will not able to get the important complex relationships in our data. And that's where again the concept of deep learning came into picture. So with this, let's end this video. I hope that you find this video insightful. This was the very first session with respect to machine learning, and I just want to give you a gist of what is machine learning. Now in the upcoming videos, I'll start with the supervised machine learning and will go in very much depth, and I'll make sure that I'll talk about the mathematics part in each and every video with respect to the algorithms that I'll cover up. And I'm expecting that you all are super excited with this particular new journey as well. So please hit like button, do share this video with everyone whosoever is in need with respect to this particular concept. At least I got so many requests with respect to starting this particular new playlist, and that's why I'm doing so. So please support me and do subscribe to my channel. It will really mean a lot to me with this, and I'll see you all in my next video.